let's get the equation. If we superimpose the fundamental with an amplitude of 2 centimeters with a second harmonic of amplitude 1 centimeter on a string of length 4 meters where propagation velocity is 80 meters per second. Now, the propagation speed is 80 meters per second. A string of length 4 meters, the fundamental is going to have a wavelength of 8 meters, giving you a sine of pi over 4 radians per meter times x. Now, you should understand how to make that transition. I'm not going to explain it in detail right now. Simply test the fact that if you change x by 8 meters, this changes by 2 pi, and that verifies the quantities here. You multiply that by the 2 centimeters, that gives you your basic amplitude function. You multiply that by the sine of 20 pi radians per second times t. Why 20 pi radians per second? Because an 8 meter long wave moving at 8 meters per second will go through 10 cycles in a second. 10 cycles is 20 pi radians on the reference circle. The second harmonic has a wavelength of 4 meters, for reasons that you should understand by this point. And you multiply 1 centimeter then by the sine of pi over 2 radians per meter times x, pi over 2 being what you would multiply by 4 meters to get 2 pi. And the frequency of that wave, a 4 meter wave, moving at 80 meters per second, is going to complete 20 cycles in a second, 20 cycles being 40 pi radians. So we have the time dependence as 40 pi radians per second times t. Now, I'd recommend that you try to understand all that so that you could duplicate a solution to this kind of a question. And then graph this thing. Now, you should be able to graph this by hand, but it would help you to see a really good picture, so feel free to graph it on your calculator, but you should also go off to the side and graph it by hand to see that you really understand how to construct a graph of a function of this nature. Graph this function for t equals 0, 1/80th, 2/80th, and yes, I know that reduces to 1/40th, but I want to get the sequence here, 3/80th up to 8/80th, which of course reduces to 1/10 of a second. And see if you don't get configurations very much like the ones we developed in the preceding video. So you want to graph each wave, each individual wave, this one, and graph the superposed wave and see that this analysis really works.